Hello and welcome to another video, this time on Stats 2018, question 1, and this is a discrete random variables question. Now, what is a discrete random variable? Really, discrete random variables are always about a table of probabilities and the associated values that a probability takes. I normally think about dice or scores on a spinner. If a spinner's being spun, there's different sections on the spinner with scores and their associated probabilities. That's what a discrete random variable really is, or it's the best way of looking at it. It's about probabilities in tables. Now, okay, what have we got here? We've got Helen believes that the random variable C representing cloud cover. Okay, this is about large data set. Cloud cover is always measured in octals, yeah? And when this paper first came out, we realized, wow, they're really going to make some really difficult questions from the large data set, because you had to know that cloud cover is measured in octals. And all that is eighths of the sky covered by cloud. And it's done by guess. You just kind of like basically look up and think how many eighths of the sky are covered by cloud, and then you write that down, and that's how many octals of the sky are covered by cloud. But anyway, they want us to write down the probability distribution. Now, if you're ever writing down a probability distribution, that always means a table of values. So you've got C, probably that capital C equals little c. And apologies, for some stupid reason, I've decided to do this video right on changeover time between lessons. That's a silly idea. Okay, we're going to have to go. Remember that naught's a possibility. It's possible for no parts of the sky to be covered by cloud. And this is what's going to stitch people up when you see this first question. As soon as we read it in the paper the next day when we saw the exam, we were like, they're going to hate that. Because that's actually ninths, isn't it? Because you've got the probability of 0 as well. Now, the reason they're all ninths is because it's discrete uniform. A uniform probability distribution is one where all the probabilities are the same. That's what a uniform distribution means. So, okay, we've got ninths all the way up until the end, yeah? And that's the first couple of marks for A. That's a probability distribution of C. Okay, using this model, find the probability that the cloud cover is less than 50%. Well, less than 50% means less than 4, yeah? And if you want C to be less than 4 here, that's these 4 possibilities. 3, 2, 1, or 0 eighths of the sky covered by cloud. And so the answer is 4 ninths. So this question is easy when you know how to do it. It really is. But, you know, I can see this catching people out in exam conditions, particularly on the very first year it was sat. It's like, that's a really nasty question. Okay, Helen used all the data from the large data set for Hern in 2015 and found that the proportion of data with cloud cover of less than 50% was 0.315. Comment on the suitability of the model. Well, our model suggests that this should be 0.4 reoccurring, yeah? And that is not that close. It's not that close to 0.315. In other words, like when Helen's looked at the real data of how cloudy it is, she can see that actually it's more cloudy than not. And that's certainly matching up with what I'm looking at outside right now. It's a cloudy day. It's always cloudy, isn't it? And this is the point. And uniform distribution is not appropriate for cloud cover. Yeah, and this is where, you know, sorry, I should finish off part C. So the model does not look appropriate. So the model looks unsuitable. Yeah, because the data is telling us, the real data, that it's more cloudy than not. Yeah. Okay, so the model looks unsuitable. We'll check these answers in a second. I like to look at my wordy answers and see how close I've got to theirs. Okay, suggest an appropriate refinement to Adam's model. Okay, I would suggest that it's not a uniform distribution. Yeah. Now, that's probably not going to get you the whole mark. You know what it's like? They want a refinement. All I've said is this isn't any good. That's not refining the model. Refining the model means making it better. Yeah, so suggest an improvement, in other words, which Helen might make to make the model more close to the truth. Okay, so I'm going to suggest a non-uniform distribution. I'm going to say consider a distribution where the probabilities for cloud cover accurately reflect the likelihood of that occurring. Don't write too much in these, But, if you're paranoid of getting the mark, write a couple of sentences, but you don't need a paragraph, that's for sure. Consider a distribution where the probabilities for cloud cover accurately reflect the likelihood of that occurring, e.g., in the UK it's cloudy, more cloudy than not. So use greater probabilities for 5, 6, 7, and 8. For probability that C equals 5, well, that C is greater than or equal to 5. Let's just put so we can do it all in one go. Okay, and hopefully it'll get me the mark. Let's have a look, because I always copy these down. This is a good thing to do, I think, on these wordy questions. So these are fine, obviously. Probability lower than expected, so the model is not good. Yeah, exactly. And then cloud cover will vary from month to month and place to place, so use a non-uniform distribution. I don't feel like that's, well, using a non-uniform distribution is good, because that is a refinement, but this isn't really a refinement. Let's have a look what it says in the notes. Sensible refinement considering variations in month or location. Just saying not uniform is B0. There we go. But have I got the mark? Just refined model. Model must be outlined and discrete and non-uniform. Yeah, good. I've done that. Higher probabilities for more cloud cover or lower probabilities for less cloud cover. Good. So we got the mark, yeah? But always look at these wordy bits, particularly in the notes, not just in the mark scheme at the top. Look at the notes and you'll gradually find yourself getting closer and closer to the answers, hopefully, yeah? Okay, hope that was useful. All the best and keep up the hard work. Bye-bye.